Right, hopefully you've done a little bit of research. You've looked at all the different uses of electromagnets. But one thing I hope you realise is that there are many different devices, machines, applications of electromagnetism in the real world, but in our everyday life. Anyway, first thing we're going to look at, well, this is what today's lesson is all about. It's looking at uses of electromagnets. Now, one I showed you last lesson was this one here. If you remember that I showed you how to make an electromagnet. It's as simple as this. You get a long piece of insulated wire, has to be insulated. Now I've actually twisted together several shorter lengths of wire to get one long one. That's what these little bits of tape are here. This is just the connections. And then you wrap it round. Now in this case I've got a soft iron core. Has to be soft iron because soft iron can be magnetised and demagnetized at the flick of a switch. But anyway, we last lesson looked at how it can be used to pick things up. Just wait for the voltage to come. There you go, so around about 1 volt. So it's the voltage that produces the current in the coil, and the current in the coil turns it into a magnet. It produces that magnetic field. And as we can see, that magnetic field can pick up some steel nails. Beauty of electromagnets, this is why they're so useful to us in many different applications, is you can turn them off at the flick of a switch. Now, if you remember from last lesson as well, we just simply turn up the voltage, therefore turn up the current in the electromagnet, and that will make it much stronger. Okay, there we see, picking up all of the nails quite successfully. But again, the beauty is we can turn it off at this flick of a switch. There's a few still hanging on there because they've retained their magnetism, because like I said, these nails are actually made of steel, and steel can be permanently magnetized. So there's a little bit of magnetism still in the steel nails there. But anyway, that's the simple electromagnet. Now hopefully some of you, or most of you, or even all of you, found the first application of that would be as a junkyard crane. Okay, junkyards where cars go to retire when they're scrapped. Rather than picking up the scrap cars with a crane with a claw mechanism, we just simply use a very strong electromagnet which can pick them up, because cars usually have quite a high iron or steel content, and they can drop them by turning off the electromagnet. Anyway, application number 2, or device number 2, is the electric bell, which is things we're all familiar with the sound of, where we hear them several times a day in school. But how do they exactly work? Right, let's just remind ourselves about what they sound like. So connecting with the DC power supply there, turning on, waiting for the voltage to appear, and the bell starts to ring. So what have we got here? Sounds nice, doesn't it? Anyway, how is it making the sound? Well, this bit here is the hammer. This is being pulled across and it's hitting the bell, which is making the sound. And it's repeating that at quite a high frequency to make the bell sound. But exactly how do they work? Well, they're an electromagnetic device. So inside is an electromagnet. So there they are, okay? 2 coils of wire. 2 insulated coils of wire. Inside you can just about see maybe. There's a soft iron core going through each. Now these, when there's a current flowing through them, turn into electromagnets, and they pull the hammer across. Can you see that there? So the electromagnets, because this is called the armature. This is made of steel or iron, and this is pulled across, and then it rings the bell, right? But if the current stayed on in these, it'd be pulled across and it'd only ring once, which would not be very good. So how does it repeat? Right, well, it's all down to this part here. Now, hopefully you can see there, when the hammer is pulled across, it breaks the circuit here. It breaks the circuit here, and in doing so, switches off the electromagnet. Now, if the electromagnet gets switched off, the hammer springs back to its original position again. When it springs back to its original position again, it reconnects and turns the circuit back on again. Turns the circuit back on again, the electromagnets turn on and pull the hammer back again. But the hammer gets pulled back and the circuit breaks again. And so it keeps repeating several times a second. Okay, so there you have it. The electric bell using electromagnets.